No, don't do this. No. Okay, hello, you're welcome to my channel. Now in this video, okay, I'm going to solve this problem. Now this problem is a sample, okay, of the kind of problem I'll be setting for my students. So we have to find the real range of f of x to be the 2 times the square root of x. Then we divide that by g of x, where g of x is just a piecewise function. Good. Okay. Well, to find the range of a function, we need to first of all find the inverse of a function, and then we look at the domain of the inverse of that function. But here, it is impossible to do that. Well, if you can do it that way using this piecewise function, maybe you can go ahead and compose that in the comment section. Okay, good. Okay, so what I'll be doing here is to well, one standard way of finding the range, which is a set that contains all the output, is to get all the inputs of the function and then substitute them into the function, and then they'll give you the corresponding output. Okay, notice that. But what if the domain contains infinitely many elements? It may not really be possible to get out infinitely many elements in the range set just by substituting each of the elements in the domain. So maybe if this function is an increasing function, that might help, or a decreasing function, because from there we observe the pattern. But anyway, let's see what we've got. We have f of x to be the 2 times the square root of x, then divided by g of x, which is 1. If x is less than 0, it will be 0 if x is greater than 1, and it will be the floor function. Okay, this right here is a floor function, or you call it the greatest integer function, if x lies between 0 and 1, with 0 and 1 included. Good. Okay, well, let's just start by solving for the domain of this function, and then when we get the output, okay, when we get the domain, we can look at how to find the range of this function just from the domain set. Good. Okay, so let's look at that. Well, the domain of a function means every input, okay, that will make the output to be defined, and by the output we mean that we will have a result from the function. Good. And we'll be looking at only real numbers as a result, because here we are talking about the real range. We do not want complex numbers as the output, so we only want real numbers. And because of that, we will look at the numerator, which has a square root function. So there we have 2 times the square root of x. Well, the square root function is only defined for non-negative input. That is to say, for us to have the square root of something to be a real number, then that thing must not be a negative number. Okay, so for that, I'm going to start with the case 1. The case 1, I'm going to put it down as that the input, which is x, should be bigger than or equal to 0 in order for the square root of the numerator to be defined. Good. Okay, so since that is the case, that already tells us that we want every real number bigger than or equal to 0 to be the input in order for the numerator to be defined. Great. Okay, so the next thing is to consider the denominator. So maybe I can put it down here as a case 2. Okay. Good. The denominator there, since this is a fraction, okay, we do not want the denominator to be 0. Now, the denominator is g of x, and g of x will be 0. Okay, that means if g of x is 0, that means that function will be undefined. So we are looking for values of x that will not make the denominator to be 0. Good. Okay, so let's see what the g of x has. G of x is 1 if x is less than 0. What that tells us is that as long as we keep plugging a negative number, that is numbers less than 0, the output of g of x will not be 0. So that means that if x is less than 0, then g of x will only be 1, okay? That means g of x cannot be 0. So the values of x, or negative values, okay, will make the g of x to not be 0, okay, to be non-zero. That means that maybe the negative numbers can be taken, okay? That means we can say that x should be less than 0. But notice, here we say that x should only be bigger than or equal to 0. That means we do not want x to be less than 0. That already tells us that this right here will not be taken, right? So the first function, or the first subfunction, fails. Good. The second subfunction already tells us that g of x will be equal to 0 strictly if x is bigger than 1. That means that whenever we plug in numbers bigger than 1 into the function, g of x will attain the value 0, which is just a constant function. So what that means is that for g of x not to be 0, x should not be bigger than 1, okay? Now, let me put it down here that g of x will be equal to 0 if x is bigger than 1. So this tells us that x should not be bigger than 1, and that means that x should be less than or equal to 1. So you notice that argument over there. So we only want real numbers less than or equal to 1. And again, we only want real numbers bigger than or equal to 1. That means we are confined in a particular region, which means that our x should only lie in this interval from 0 to 1 with 0 and 1 included. That is a closed interval. Good. Okay, but we've not considered the third subfunction yet. This will actually help us to determine the particular domain of this function. Okay, so the third subfunction tells us that g of x will be the floor function of x, or you call it the greatest integer function of x, if x lies between 0 and 1 with 0 and 1 included. That makes sense over here because here we are at that domain, 0 and 1. So if x lies between 0 and 1, then g of x will become the floor function of x. Well, by the definition of this floor function, it tells us that whenever we have the floor function of a particular number, okay, the result will be that number if that number is a whole number. So the result will be n if n is an integer. For example, if n is 2, then the floor function of 2 is just going to be 2. But the floor function of n, if n is not a whole number, then it will now be a decimal number, okay? The floor function will now be the greatest whole number less than that decimal number. For example, if we have 1.6, okay, the floor function will truncate it, leaving us with just the whole part, which is 1. So by floor function, the output must always be a whole number. The output would be the identity if that number you plugged in was a whole number. Otherwise, the output will be truncated to become a whole number less than the input, okay, and the greatest whole number, in fact. Good. Okay, so what that tells us is that as long as x lies in that interval, x can be 0, x can be between 1 and 0, and x can be 1. Now, if x is 0, then by the definition of the floor function of x will just be 0, because 0 is a whole number. Good. Now, if x is anything between 0 and 1, with 0 and 1 excluded, the floor function of x will be equal to 0. Because by saying any number between 0 and 1, for example, 0.1, the floor function will take us back to 0, because 0 is the greatest integer less than 0.1. If x is 0.9, then the floor function will take us back to 0, because 0.9 is the greatest integer less than or equal to, because 0 is the greatest integer less than or equal to 0.9. Good. Okay, so the only way that the floor function will not be 0 is if x is equal to 1, which lies in that interval. So let me just put it down here for you. If x is strictly equal to 1, then what that tells us is that the floor function of x will just be that 1, because 1 there is a whole number. Good. Okay, so all in all, what this means is that the floor function, which is going to be the g of x, will be 1 whenever we have x lying in this interval, okay? Now, the floor function g of x will become 1 if x is equal to 1, otherwise it will become 0. And if g of x is equal to 0, that means the function will be undefined. So the only value of x that will make this function to be defined is 1. Because if you plug in 1 into the first case, well, the first case is that g of x will be 1 if x is less than 0. 1 is not less than 0, so we do not talk about that. Now, the second case tells us that g of x will be 0 if x is strictly bigger than 1. Well, it's not bigger than 1, so we cannot look at the second case. The third case tells us that g of x will be the floor function of x if x lies between 0 and 1 with 0 and 1 is included. So you notice, if x is 0, this will be 0, meaning the denominator is 0. If x is between 0 and 1 with 0 and 1 excluded, then the floor function will still take us back to 0, meaning the denominator will be 0. The only way the denominator is not going to be 0 is if x is equal to 1. So what that tells us is that x equal to 1, x equal to 1 is the only real number, okay, for which the function is defined. That means that the domain is a singleton. It contains only the real number 1. So the domain of f is a set containing only 1. Good. Okay, so this domain here is very nice because with this domain, we can find the range very easily. And that is motivated from the fact that the domain of a function, or in fact, the definition of function, a function is a rule, okay, that takes one input, and when it takes an input, it produces exactly one output for each input. That is to say, since the domain consists of only the element 1, the range will also consist of only the element 1, because this will not be a function if we plug in 1 and get more than one element. And 1 will not be in the domain if we plug in 1 here and we do not get a result. So we can only plug in the 1 and then we can only get one output from that. That means the range will also be a singleton. Good. Okay, so we can get the range immediately by plugging in the input, which is 1 in place of x. Okay, maybe let me clean the first case and the second case and then we'll do that right away. So that means that f of 1 will become, well, you plug in 1 into the function, we just have to evaluate it, all right? So we plug in 1 in the place of x, that will become 2 times the square root of 1. Well, the square root of 1 is just 1, so that's 2 times 1 divided by g of 1. Now, since x is 1, this means every number less than 0. So 0 is not 1 is not less than 0. We do not come here, rather we come here. G of 1 will be the floor function of 1, which is just going to be 1. And then all in all, we enter with 2. So this right here means that the range of the function is going to be the set containing only the element 2. So the range also is a singleton. Okay, great. That was better, all right? So if you want to be my student, then notice that this is the kind of question you'll be facing. All right, thanks for watching. Please subscribe to my channel.